Hello, my beautiful children. How are you doing today? Great, wonderful. Oops, sorry. Okay, so I'm so sorry I can't be there today. I will be back by advocacy and obviously lunch tutorials. So if you need to come see me about any of this, please do so. Or you can email me or come see me tomorrow during advocacy. Not lunch. I'm not available lunch on Thursday. But yeah, so just so you're aware, though, we are having a quiz over this, but it's going to be over 9-1 and 9-2, and it will be open note, okay? So look at the board. I wrote down your instructions for today, which is literally just watching this video and taking notes, and actually there's probably going to be a couple videos because I can only make them so long, and after that, work on your homework, which is online, one part, and then make sure you're preparing for your quiz next time, which is going to be over 9-1 and 9-2. Open note. Okie dokie. Yay math! Yay math! Okay, great. That was so fun. So, let's start by talking about regular polygons. What is a regular polygon? A polygon is a shape with all straight lines, no curved surfaces. So 3 or more lines that all connect to form this closed figure. But the regular part of this, that means that all the sides are congruent. So it's a polygon with all congruent sides, which also means all the angles are congruent. Okay? So just like with our other shapes, there's a formula to find the area of regular polygons. However, before we do that, we're going to look at other ways to find the area, okay? Just so you can have a background idea of how to do that, okay? So in general, we're going to look at, let's start with the pentagon. Pentagon has 5 sides. And as you're drawing these, if you would like to, if you go over to the bookcase by the window, there's this yellow box thing, and that has the geometry templates, so like stencils. And it has pentagons, hexagons, triangles, other regular polygons that you can use to kind of draw your shapes. Or you can just sketch it. But if you want to go get that now, do that. Alright, so we're going to start with the pentagon, which has 5 sides. So, assuming, let's just pretend like there's no formula for the area of a regular polygon, even though there is. I'm just not telling you yet. Haha. Don't skip to the end of the video. Just kidding. But don't. But let's assume we don't know that, and we want to think about what other ways could I find the area of this regular polygon. So all these sides are congruent, right? So you should always ask yourself, how can I make this into different figures, right? If I draw, for example, here to here, well, that's going to be a triangle and a trapezoid, right? So I could do that. But what I would need to find is the height, right? Height here, the height here. I would also need the bases and all of that, okay? So that's one way. Could do that. Let's see. Some other ways are going to be, let's get rid of that. Excuse me. If I have the center of it here, this one's a little different here, but this is the best method, is if you draw the segment from center to a vertex, and do that every time. So here to here, here to here, here to here, ooh, here to here. Ooh, okay, let's pretend like they all meet. Let me try that again. Okay. So pretend like they're all equal, because they should all be equal, right? Why should they all be congruent, you ask? Well, all those lines that I just drew are the same, because they represent like the radius of a circle if I had a circle inscribed, or if this pentagon, sorry, was inscribed in a circle like that. All of those would be radii, and they're all the same. So, another way I can find the area of this pentagon is by finding the area of one of those isosceles triangles and then multiplying it by however many there are. And hey, look, there are 5, because that's the number of sides. And that would give me the area of this pentagon. Only because it is a regular pentagon, meaning all the sides are congruent. So if I wanted to find the area of this triangle here, and then multiply it by 5, the formula for the area of a triangle is what? 1/2 base times height. Good job. Yes, you're right. 1/2 base times height. That's a triangle, right? And then I would multiply it by 5 because there's 5 triangles. Well, let's look at what I have there. The whole base would be this piece here, right? So we're going to call that S for side length. Could call it base, but it's a little confusing when we talk about polygons. We always refer to S as the side length of polygons, okay? And then the height would be this segment right here. So that is the height of the triangle. We're going to call that something else, and this is a very important vocabulary word that you need to write down. So that segment that I just drew is what we call the apothem. Sounds really weird. I promise I didn't make it up. Kind of sounds like a possum, but with a little bit of a lisp, so apothem. Try it out. Say apothem. Do it. Just kidding. You don't have to do it. Okay, so what that is, it's a segment. Let's write this down. Segment from the center of a regular polygon that goes perpendicular to the side. Okay, that's 1, 2, okay. All right, so that's apothem. So we're going to call that, guess what? A. A for apothem. So I'm going to go back to my formula here, and I'm going to plug that in. So I said the base of the triangle is side. The height of the triangle, we're now calling A for apothem. And then here's where I'm going to change this up a little bit. Now, 5 is the number of sides in this polygon, right? But I just chose pentagon as an example. What if I had picked a hexagon? Then this number would be 6. What if I picked a decagon? Do you know how many that is? That's 10. So this number would be 10. So this number right here represents the number of sides in the polygon, right? So, if that's the case, I can use this formula right here, the area of just a shape in general, as 1/2 of the side times the apothem times n, where n represents the number of sides. So that is going to give me not the area of a pentagon anymore, but the area of any regular polygon. Okay. So there's kind of a different way of writing that, though. Here's how I like to write it. I like to put all of these variables here, s and a and n. I like to put them in the numerator and then just divide by 2. So I'm going to put the n first times s times a over 2. NSA over 2. See how easy that is to remember? Because NSA, it's hilarious. So that's area of regular polygons. So that's our formula. That's the formula I prefer to use. There is a different one. I mean, it's basically the same thing. Just looks different. It's, I believe, what your textbook uses, so I'm going to write it down so you can see it. Use green. It has to do with the perimeter, right? Okay. So instead of NSA over 2, if I want to say, I'm going to put this in terms of the perimeter of the regular polygon. Let's think about that. Perimeter is adding up all the sides, right? But if they're all the same, I could just take the side length and the side length and multiply it by however many sides there are. Okay, well, n times s, that right there, is n times s in my other formula, NSA over 2. So if I replace this and I put apothem times perimeter over 2, that's also going to give me the area of a regular polygon. Okay, so both of those are literally the same exact formula. Please don't think that they are different. They are the same. You can use whichever one you want to use. If they give you the perimeter already, then use AP over 2. But if you can't remember that and just do NSA over 2, that's fine too. Okay, so make sure you know what all of these variables stand for. N is the number of sides in your polygon. S is the length of the side. Side length. A is the apothem. Okay? So that's how we find the area of a regular polygon. Isn't that fun? Shall we do some examples? Okay, let's. So I'm going to pause this and go to the next video because it's probably not going to let me do a video for much longer.